link performance prediction and network trace tools. We are in the process of releasing a network trace toolkit intended to make it easier for developers to test and develop for different network characteristics. This could, for example, be to experience how a fast 5G millimeter wave connection would appear, or dropping down to 2G GSM edge connection, or anywhere in between. But the main focus is to give an experience of the dynamics in the network, how the connectivity changes over time in different networks around the planet. As a developer, you can thereby easily test your applications as if you were in the New York subway, hiking in rural Sweden, going on a train in South Africa, or biking along the rivers in Seoul. The toolkit comes with 4 main deliverables: the trace emulator that replays a network trace and as needed throttles the connection in the browser, the trace collector so anyone can go out and generate their own network trace, a pre-collected set of traces from around the globe. Last but not least is the specification of the file format. The material is released under GPL2 and we encourage feedback and contributions, both to collect traces but also to take the emulator and collector tool forward. The material is just about to be pushed out to our GitHub repo, so keep an eye out. But let's see how the emulator tool works. This is a dev tool extension and loads as such. You then pick the trace file, and in this case it is the car trace 4. And you can see here in the graph to the right how the download bandwidth varies, as well as an optional map with the GPS position below. We can run some speed tests and see how the bandwidth is throttled according to the current set of link capabilities. It is easy to move back and forth in the trace. The emulator works with any web page and will impact your experience accordingly. With the trace emulator, you can experience the network changes and see how your application copes with them. However, what if your application was aware of the changes ahead of time? Could it handle the changes better then? Better leverage the peaks and preemptively handle the valleys. The trace emulator has a set of fields below the graph, and that's where the link performance prediction comes in. But let's give it a quick introduction of the technology, which is in development and early trials now. Link performance predictions, or LPP, is a technology that interfaces to an operator's network and brings out quality awareness of the client's connection to the client application itself. This is both for current quality but also forward-looking predictions of the link characteristics. LPP does not by itself touch the data, and the information is provided as hints to the application so that themselves can decide of the best actions. LPP works in the operator network by collecting and analyzing metrics that is already available. No sensitive data is shared, and only the client receives information for its own link. There is a wide set of usages for this, but let's consider an example in media streaming. For this case, we have modified the MPEG- reference player and adjusted the buffer length according to the LPP predictions. We can see a bandwidth drop, then we increase the buffer to cover that gap. On the left side is a standard player, and on the right side the same player but with LPP capability, which here allows us to proactively buffer and avoid stalls in the video stream. Your application can easily pick up the predictions from the trace emulator. In a real-world scenario, with LPP and the network, you would instead receive those from the LPP server. We have a simple application that allows you to subscribe for predictions that then are displayed, but you can obviously have more elaborate use of them. The prediction time window and change sensitivity can be adjusted. That's all for today. I hope you enjoy our new tool. Thank you.